When the pH is 7, then it's a case where the sample is neither acid nor base. But less than 7, it's an acid, we say. More than 7, it's a base all the way.
Welcome to another past HSC exam question videos on acids in the pH scale chapter. While doing a second, I'll read the actual question. Once you read the question, give about 5 seconds to pause the video. Once you pause the video, attempt the question, and then press play when you're ready again. The question itself is: solutions of hydrochloric acid, acetic acid, and sulfuric acid were prepared. Each of the solutions had the same concentrations, 0.001 molar per liter. The pH of acetic acid solution was 3.4 pH. So these are the three solutions: so 0.01 molar of hydrochloric acid, 0.01 molar of acetic acid, and 0.01 molar of sulfuric acid. And the only one that was given was the pH of 3.4 for acetic acid. A. Calculate the pH of hydrochloric acid solution with 1 mark. B. Compare the pH of sulfuric acid solution to pH of hydrochloric acid solution, and no calculations are required. That's worth 2 marks. And then we've got explain why acetic acid solution has a higher pH than hydrochloric acid solution, and that's worth 2 marks. So when you're ready, press pause and attempt the question, and then press play when you're ready. Welcome back. My first question is 3 parts. Let's tackle the first one first, A. And that's a relatively simple one. All it says is calculate the pH of hydrochloric acid. So of this solution here, we've got the 0.01 mole given, and we know that hydrochloric acid completely dissociates when it comes in contact with water to form hydronium ions and also chlorine ions. Now we have 0.01 molar of this, which means we'll also have 0.01 molar of this because it completely dissociates, so this will turn into this, 1 for 1. Now it says calculate the pH of hydrochloric acid. So we know we've got 0.1 molar of hydrogen ions, and then we can actually calculate the pH using this formula here. So if you type in minus log of 0.01, 0.01, it's meant to be 0.01. So if you type minus log the concentration of bracket 0.01, you will get your pH, and that should be a pH of 2. Should be a pH of 2. And then what you can do next is you do B. So we'll do B. So for this A part, all you have to do that calculation, and that would have given you your pH of 2. So compare the pH of sulfuric acid solution to the pH of hydrochloric acid solution. No calculations are required. So again, first thing you mentioned would be that both of them are strong acids. Both sulfuric acid and hydrochloric acid will be strong acids. So therefore they have a lower pH than, for example, your acetic acid or your citric acid. But you should also mention that sulfuric acid is actually a diprotic acid. And what that means is you're going to have, on some of them, you're going to have 2 molecules ionizing, or 2 hydrogen ions ionizing from that structure. And that means sulfuric acid might actually have a slightly lower pH than hydrochloric acid, because if 2 hydrogens per sulfuric acid ionize, then you're going to have more hydrogen concentration, and that gives you lower pH. So that's what I wrote. So first, compare the pH. What I wrote first is both sulfuric acid and hydrochloric acid are strong acids, and will have a lower pH compared to acids such as acetic and citric acid. I'll get you marked. We just compared and said they're both strong acids. Then what I wrote next is sulfuric acid has a slightly lower pH than hydrochloric acid, as sulfuric acid is a diprotic acid, which means that 2 ions can ionize, resulting in a higher concentration of hydrogen ions. Alright, so for this case, we've got hydrochloric acid. For every hydrochloric acid, we've got 1 hydronium. And for sulfuric acid, you sometimes have 2 hydroniums per sulfuric acid, in some cases ionizing, which means we have slightly more hydrogen ions, and slightly more hydrogen ions means we have a slightly lower pH. So if sulfuric acid can have a slightly lower pH, same concentrations than hydrochloric acid does. And that will also get you marked. Just mentioning that there's a slight difference between pH between the two, even though they're both strong acids. Okay, again, gets you 2 marks out of 2. And the last one was explain why acetic acid solution has a higher pH than hydrochloric acid solution. And in this case, so we have acetic acid here, pH of 3.4, and we know that in this case this hydrochloric acid has about a pH of 2. And you would talk about the ionization, that hydrochloric acid completely ionizes, which means that 0.01 molar will turn to 0.01 molar. So 0.01 molar of hydrochloric acid will turn to 0.01 molar of hydronium ions. That means we have a high concentration of hydronium or hydrogen ions. And for acetic acid, it does not completely ionize, it only sort of partially ionizes. And what that means is that for the same concentration, we'll have a lower concentration of hydrogen ions. So we'll have a lower H plus concentration. And if you have a lower H plus concentration, we get a higher pH. So that's what I wrote. So first I said pH is a measure of hydrogen concentration. The more hydrogen ions in the solution, actually I should have been, the more hydrogen ions in the solution, the lower the pH. Hydrochloric is a strong acid, which means that it will completely ionize, resulting in a high concentration of hydrogen ions in solution and a low pH. That's why the hydrochloric acid has a relatively low pH, because it completely ionizes, which means you have a high concentration of hydrogen ions. Whereas for acetic acid is a weaker, not weak, it is the weakest, but the most important part is a weaker acid, meaning that not all molecules will ionize, resulting in a lower concentration of hydrogen ions and a higher pH. Right, so some molecules will stay intact, and some will ionize, whereas with hydrochloric acid all will ionize, which means we have more hydrogen ions for hydrochloric acid than for acetic acid, which means acetic acid has a higher pH, because the lower the amount of hydrogen concentration, the higher the pH. And that gives you the answer for this part. So we mentioned that complete ionization for hydrochloric acid and incomplete ionization for acetic acid, and we link that to the idea of pH. And that's those are 2 marks. And where these questions come from, they came from these various dot points. So identify acids including acetic acid, citric acid, hydrochloric and sulfuric acid. And as you can see, the ones were given here were hydrochloric, acetic and sulfuric acid. So they were the ones mentioned because they were also in a dot point, this one, and this one. Describe the difference between a strong and a weak acid in terms of an equilibrium between the intact molecule and its ions. And that was question C, came from that one. Question B actually, so the fact that sulfuric acid is diprotic and hydrochloric acid is monoprotic, that came from here. And the calculation of pH, this came from, there's a couple of dot points that tell you need to be able to calculate pH given concentrations. And this was maybe one of them, but there's other ones as well. But I hope that was useful.
Thank you for watching.